All right, Algebra 2 and Honors Algebra 2. Here we are for the Chapter 5 test review video. Got 40 questions here in this test review video. First page here, looking at simplifying in some sort of way, multiplying or dividing with the same base. Number one, here's exponent rule number one. You're going to add the exponents. You're going to take x to the fifth plus -3 to give you x squared. Y to the -2 plus -7 to give you -9. Z to the 4 plus -6, of course, to give you -2. Of course, do 7 times 5 to give you 35. Having negative exponents, y to the -9th, z to the -2nd, those have to go south. And they'll become positive exponents then. Folks, on number 2, I want to simplify everything within this parenthesis here. 21 divided by 3 is 3. The top has more x's. 7 is bigger than -2. 7 minus the -2 is 9. The bottom has more y's in terms of the exponent. That's what I mean. 7 minus 3 is 4. Top has the highest exponent with z. 5 minus 2 is 3. Don't stop there. You got to raise everything to the 4th power now. 3 to the 4th is 81. Then I have a power to a power. I, using exponent rule number 2, multiply all those exponents by 4. And that's how I get x to the 36, z to the 12th, y to the 16th. Folks, on number 3 here, I'm going to raise everything to the -5th. So I'm going to multiply everything, all those exponents by a -5. I got x to the 35th now, y to the -25th, z to the 15th. Negative exponent would go south, become y to the 25th. All right, 4 is where we got to take our time. Notice I put everything, so that first parenthesis there, got that in blue. I'm going to square this first. Think of it as its own problem. 3 squared is 9. 4 times 2, because you got a power to a power. You're going to multiply those exponents. So forth, and handle everything here in red on its own. 2 to the 3rd is 8. Multiply those exponents, multiply those exponents, multiply those exponents. Now this looks like number 1. 9 times 8 is 72. Add the exponents now. So, exponent rule number 1. From page 1 of your 5-1-5-4 game plan. Add the exponents. All right, so I have a negative exponent for y to the -5th. That would go south, become y to the 5th in the denominator. 5, hopefully pretty easy there. Just subtract. You got 7 minus 3 is 4. 9 minus a -11. Up here, that would be 9 plus 11, 20x. 17 minus a -17 is 17 plus 17, 34. All right, on 6, again, it looks like you're in a FOIL, but you're going to distribute. You have 2 terms by 3 terms. That's going to give you 6 terms that you'll simplify. X times x squared, x times 4x, x times 3, -4 times x squared, -4 times 4x, -4 times 3. All right, simplify like terms. The x squareds cancel. You have minus 13x minus 12. 7 is just a little bit more interesting than number 5 here. I'm going to multiply everything in this first parenthesis by 5. I'm going to multiply everything in the second one by a -6. A negative times a negative is a positive there. 10x squared minus 6x squared is 4x squared. -15 plus 30 is 15. 35 plus 42 is 77. And then 6 and 8 are basically the same question. You've just got coefficients other than 1 attached to x here. Okay, you're going to 2x times x squared, 2x times -8x, 2x times 5, -1 times x squared, -1 times -8x, -1 times 5. All right, combine like terms. There we go. Page 1. Good chance you'll see, 7 of those 8 at least. You might see them all on your exam. All right, so then here, number 9, going to divide all by 9x squared. Everything is divisible by 9, and everything at least has x to the 2nd. So 45 divided by 9 is 5. You had 7 x's, take 2 away, now you got 5. Minus 36 divided by 9 is 4. You had 4 x's, take 2 away, 2. 29 divided by 7 is 3. You had 3 x's. Take away 2 in the exponent, so that's x to the first. On 10, the same thing. I'm going to try to divide everything by 5. X to the third, y to the second, because everything is divisible by 5. Everything's got at least 3 in the exponent of x and at least 2 in the exponent of y. 50 divided by 5 is 10. 7 is the exponent, subtract 3, 4. 3 is the exponent, subtract 2, 1, minus. 40 divided by 5 is 8. 4 is in the exponent, subtract 3. 7 is the exponent, subtract 2. Let's talk about number 11. I'm going to divide by x plus 2. All right. When I do synthetic division, again, here I'm dividing by 2 terms. On 9 and 10, I was just dividing by a single term, 9x squared, 1 term, nothing in between it. 5 x to the third, y squared, nothing in between it, all right? X plus 2, that's 2 terms. So I need to do synthetic division. I set what I'm dividing by equal to 0. Not only am I asking, is x plus 2 a factor, but is x equals negative 2 a solution? All right, 3 for 3x to the third, negative 7 for negative 7x squared, 8 for 8x, 13 for the constant. Again, I'm doing 3x to the third divided by a single x. 3 divided by 1 is 3. That's why I can bring down that first term. And then for synthetic division, I multiply and add. I take that number in the cubby, negative 2, and I multiply it by 3 to get negative 6. Then I add the columns. Negative 2 times negative 13 is 26. Then I add the columns. Negative 2 times 34 is negative 68. Then I add the columns. So no, x plus 2 is not a factor. I have a remainder of negative 55. Started with 3x to the third, and then I divided by x to the first. So I need to drop a power. This 3 is for 3x squared. Minus 13x plus 34. Minus, because it's negative, 55 over what I was dividing by. Then 12 divided by x minus 1. So I set x minus 1 equal to 0. Put 1 in the cubby. Is 1 a solution? 4 for 4x to the fourth. 0 for 0x third. Again, I'm starting the countdown at 4, and I need to say 4, 3, 2, 1, x to the 0. So 0x to the third, negative 2x squared, 8x, 4x to the 0, or 4 as your constant. Bring the 4 down. 1 times 4 is 4, add them up. 1 times 4 is 4, add them up. 1 times 2 is 2, add them up. 1 times 10 is 10, add them up. 14 is your remainder. 4x to the fourth, divide by a power of x. So this is going to be 4x to the third plus 4x squared plus 2x plus 10 plus your remainder over what you're dividing by. State the degree and leading coefficient of each polynomial. The degree is the highest power. All right, these probably won't be written in standard form. So the highest power is 4. What is attached to x to the fourth? 8 is the leading coefficients. What's the highest power here? 5. Degree 5. What's attached to x to the fifth? Negative 40. That's the leading coefficient. All right, so 15 and 16 determine whether the graph represents an even degree or an odd degree function. State the number of real zeros. On 15, take a look at the arrows. They are going in the opposite direction. Opposite direction means you have an odd degree function. Think of the alliteration. Opposite odd. How many times does it cross the x-axis? 1, 2, 3 times. Not 4. We don't care here about the y-intercept. 3 real zeros. Take a look at the arrows in 16. They are going in the same direction, so it can't be odd. Same direction is an even function. How many times does it cross the x-axis? 2 times. 2 real zeros. And we are rolling. All right, so then we have a few more easy questions here, 17 through 19. You give me one of these 4 graphs. That one, that one, that one, or that one. All right, here's how we can help ourselves out. These will be written in standard form. So the leading coefficient is positive. If the leading coefficient is positive, the graph has to end by going up. The highest power is 5. 5 is an odd number, so it's odd degree. Odd degree means you have opposite end behavior. So if it ends by going up, in the other direction it goes down. All right, so the leading coefficient is a negative, so that means the graph ends by going down. Then it's raised to the second power. The highest power is 2. That is 2 is an even number, so it's even degree. Even degree means you have the same in behavior, goes in the same direction. So if it ends by going south, in the other direction, it goes south as well. And here, we got 3, which is odd degree. We have a negative, leading coefficient's negative, so it ends by going south because it's an odd degree function. The other way, it goes north. All right, gonna just have to take your time and have this memorized for 20 through 23. We got the sum of 2 perfect cubes. Again, if I have a to the third plus b to the third, I would take the cubed root of both, a plus b. Then I take that first term, a, and I square it. Because I am lacking middle terms, I have to have a minus opposite sign. Then I take the inner product, a times b, and then I square the second term. That is what I'm doing on ones like 20. So I take the third root of x to the third, that's x, plus I take the third root of 64. 4 times 4 times 4 is 64. Got my first 2 terms. Then I take x and I square it. If this is a plus, this has to be a minus. Again, there's no x squared, there's no x term. So I need a minus somewhere. Minus the inner product is x times 4, or 4x. And then I square 4 to get 16. All right, 21. 21 is in the form a to the third minus b to the third, which would be a minus b. I take the cubed root of both, and I square the first term. Again, opposite sign of the inner product, a times b, and I square either b or negative b. It doesn't matter. I get b squared again. Again, that is the form we are using. I take the cubed root of 27. 3 times 3 times 3 is 27, so the cubed root of 27 is 3. The cubed root of x to the third is just x, minus the third root of 8 is 2, because 2 times 2 times 2 is 8. I take this first term and I square all of it. 9x squared. If this is a minus, this has to be plus. We need the x squareds and the x's to cancel. Then I take the inner product. 3x times 2 is 6x. Then I square 2 or negative 2. Doesn't matter how you think of it. You get a positive 4. Oh, man. 22 would be a tough one. All right, so same type of deal. The cubed root of 64 is 4. 4 times 4 times 4 is 64. Plus the third root of 125 is 5. 5 times 5 times 5 is 125. Third root of x to the third is x. Third root of y to the third is y. So I take this first term, 4y, I square it all, 4x, I square it all, 16x squared. This is a plus, this is a minus. The inner product would be 20xy. Then I square the second term, plus 25y squared. All right, take a look at 23 here. I take the third root of 8x to the third. That's going to be 2x. Minus the cubed root of 1 is 1. The square root of 1 is 1. The 10th root of 1 is 1. Then I take 2x and I square it, 4x squared. That's a minus. This is a plus. The inner product is 2x. Then I take negative 1 and I square it, or positive 1 and I square it, and I get plus 1. All you're doing is factoring. You're not setting equal to 0 or anything. Okay, those will be hard enough. Then we get into solving by factoring. Now, it tells you to factor. It'll just say solve. I mean, you're going to employ some sort of factoring in this chapter. First off, all 3 of these terms have an x in common, so take out the x and subtract a power of x from each. Then I ask myself, what multiplies to 18 and differs by 3? 6 and 3. The middle term is negative, so the bigger factor's got to be negative, the smaller factor positive. Then I got cover-up method. X equals 0. X minus 6 is 0. X plus 3 is 0. That's how I get my 3 answers. 25 is very much like 24. Factor out the x they have in common. Put it on the outside. What multiplies this 70 and adds to a negative 17, a negative 10, and a negative 7? Cover-up method. X equals 0. X minus 10 is 0. X minus 7 is 0. Get your 3 answers. All right. 26 and 27, we're going to factor by grouping. If I have 4 terms, folks, I can't do any traditional factoring. I got to put terms together. So I've put the first two terms together, and I hope I can take something out in common. So these both, if I group them together, have an x squared in common. So I take out the x squared. So I'm going to be left with 3. If I had 3 x's and I took 1 away, it would just be 3x. Minus 2x squared divided by x squared says bye-bye to the x squared, so it's just minus 2. Then I'm going to put those two together. I always bring down the sign in the middle, so I bring down a plus. 12x and a negative 8 don't have an x in common, but they're multiples of 4. 12x divided by 4 is 3x. Minus 8 divided by 4 is 2. All right, 3x minus 2, you see it twice. That's good. They go together in one parenthesis. And the x squared plus 4 go together in the other parenthesis. Now, if I was factoring, I'd be done, but I'm setting it equal to 0. So I get x squared plus 4 equals 0, which means x squared is a negative 4, which means I take the square root of negative 4, which means I get plus or minus 2i. I root 4, and then the square root of 4 is 2. Then I get 3x minus 2 is 0, so 3x equals 2. X is 2/3. Same thing here on 27. Factor by grouping. These two have an x squared in common. 4x to the third divided by x squared would give you 4x. The 4 would remain. You had 3 in the as the exponent. You took 2 away, so you just got 1. Plus x squared divided by x squared is 1. Bring down the minus in between. Negative 20 divided by negative 5 is 4x. Negative 5 divided by negative 5 is a positive 1. Again, you need the exact same two terms in both parentheses. So 4x plus 1 goes together in one parenthesis. X squared minus 5 goes together in the other parenthesis. X squared minus 5 is 0. 4x plus 1 is 0. All right, take the square root plus or minus root 5. Then you get negative 1/4 when you solve those hopefully easy equations. Folks, we are rolling 28. 28's a big one. So I have a difference of 2 perfect cubes. So the previous page, what was that? 20 through 23, I believe. I take the cubed root of both. The cubed root of x to the third is x, minus the third root of 125 is 5. I take the first term x and I square it. If this is a negative, that's a plus. The inner product, x times 5, is 5x. Negative 5 squared or 5 squared is a positive 25. My first one is very easy. I say x minus 5 is 0. X equals 5. Then I have to use the quadratic formula here. X equals negative b, the opposite of middle term, plus or minus the square root of b squared, the middle term squared, minus 4 times what's attached to x squared, a is 1, times the constant c is 25, all over 2 times what's attached to x squared, all over 2a, which is 2 times 1. Not only do you have to use the quadratic formula, but you'll always get an answer involving I for the other two solutions. 25 minus 100 is a negative 75. So I take the I out. For a lot of you, you can leave that answer like that. If your calculator tells you that root 75 is 5 root 3, then you'll say negative 5 plus or minus 5i root 3 over 2. All right, on this next one, we're going to factor out the x that they have in common. And when I do that, everything's just going to, the exponent on the first two terms is going to be double that of 24 and 25. I'm left with x to the fourth minus 7x squared plus 12 is 0. I again ask myself, what multiplies to 12 and adds to a negative 7? Negative 4, negative 3. Instead of x times x, it's going to be x squared times x squared. That gives me x to the fourth. X equals 0. X squared minus 4 is 0. X squared minus 3 is 0. All right, so you get x squared is 4. X squared is 3. Take the square root of both sides. Don't forget about plus or minus. That's how I get my answers. 5 total answers. 0 plus positive 2, negative 2. Positive root 3, negative root 3. Those are 5 answers. All right, 30 through 32. Write a polynomial function of least degree, which has the given zeros. So I'm telling you that x equals negative 3. I'm telling you that x equals negative 1 and x equals 5. We're going to move backwards and say 5. That was set equal to 0. how would I get negative 3? It's if I had x plus 3 equal to 0, would I get x equals negative 3? Just moving those solutions over. So x plus 3 in a parenthesis, x plus 1, and x minus 5. I'm going to group those two together and FOIL them, first, outer, inner, last. I get this. Then I'm going to bring down this x minus 5, and then I'm going to distribute. X squared times x squared times a negative 5, 4x times x, 4x times a negative 5, 3 times x, 3 times a negative 5. I simplify like terms. All right, so I got x equals 0, x equals negative 2, x equals 4. So again, I would move the negative 2 over. It'd be now x plus 2. I'd move the 4 over. If it was positive on the right, it's negative on the left, x minus 4. If I move the 0 over, it's still x. X plus 0, x minus 0 is just x, so it's just going to be x. All right, so I FOILed x squared minus 4x plus 2x minus 8. Gives me that. Then I multiplied everything by x. 32, we got to be careful on 32 here. I'm telling you that x equals negative 1. I'm telling you that x equals 3i, and also x equals negative 3i. All right, anytime I get an answer of I, it's always plus or minus 2i, plus or minus I root 3, plus or minus 3i. So if 3i is an answer, negative 3i is also an answer. So what you do is you take x times x, that's x squared, equals 3 times a negative 3. X squared equals negative 9. If I took the square root of both, that's how I would get plus or minus 3i. Move the negative 9 over, x squared plus 9. Move the negative 1 over, x plus 1. And then I FOIL, first, outer, inner, last. All right, 33 and 34. So I'm telling you that x minus 3 is one of the factors to find the other two. So if I'm telling you something is a factor of something, I'm saying it divides out nicely. So we're going to divide by x minus 3. Set x minus 3 equal to 0. If I tell you that x minus 3 is a factor, then x equals 3 is definitely a solution. And let's see what we get. 1x to the third, negative 7x squared, 7x, and 15. I'm going to bring down the 1. All right, you're doing 1x to the third divided by 1x. 1 divided by 1 is 1. 3 times 1 is 3. Add them up. 3 times a negative 4 is negative 12. Add them up. 3 times negative 5 is negative 15. Add them up. Get 0. So that's going to be x squared minus 4x minus 5. What multiplies to 5 differs by 4. X minus 5, x plus 1 are the other two factors. All right, it's going to be careful here. I'm going to divide by x plus 1, okay? I'm saying, hey, take that polynomial and divide by x plus 1. That means negative 1 goes in my cubby. Do synthetic division. Negative 1 times 3 is negative 3. Add them up. Negative 1 times negative 1 is 1. Add them up. Negative 1 times negative 2 is 2. Add them up. Started with x to the third. Divide by power of x. This is 3x squared minus x minus 2. What multiplies? Oh, no, can't do that. All right, you got that 3x squared there. So I need to guess and check. I know it's got to be 3x, and I know it's got to be x, and 2 and 1 are involved. So if I put the 2 there and the 1 there, 3x, 2x, is there a way for 3x and 2x with one of them being negative? You have a negative product, that negative constant means you have a negative product. If one of these is negative and one is positive, can I get a negative x? And I can. All right. Minus 1 plus 2. And then, finally, on the last page, find the roots of each equations. Let's just solve each equation, okay? Find the roots of each equation. Instead of having f of x, I'm just going to have 0 equals on all of these. So on 35, what multiplies to 45 and differs by 4? 9 and 5, the middle term is negative, so 9, the bigger factor, is negative. 5 is positive. Cover-up method, x squared minus 9 is 0. X squared plus 5 is 0. X squared equals 9. Take the square root. X is plus or minus 3. Take the square root, plus or minus again. I root 5. All right, 36. What multiplies to 100 and differs by 15? Oh no, got to be okay at multiplication. That's 20 and 5. Middle term's positive, so the bigger factor, 20, is positive, and then 5 is negative. X squared plus 20 is 0. X squared minus 5 is 0. We get to solving, you get plus or minus I root 20, or some of you might have 2I root 5. That's fine. Plus or minus again, and then plus or minus root 5. 37. What multiplies to 10 and differs by 3? Negative 5 and 2. 5 and 2 multiply to 10 and differ by 3. That is, middle term's negative, so 5's got to be negative. X squared minus 5, x squared plus 2. Set those both equal to 0. You get x squared is equal to 5. X squared is equal to negative 2. Take the square root. Okay, we've seen plenty of this already. 38 and 40 are similar. Factor out the x they have in common. Then I do traditional easy factoring. What multiplies to 24 differs by 5. 8 and 3, the middle term is negative, so 8's got to be negative. That's got to be positive. Set it equal to 0. X equals 0. X minus 8 is 0. X plus 3 is 0.